Okay, let's talk about amides. So if you look at the last lecture notes, halfway through you can find the amide slides. There are only 2 points that we need to really go through. One, draw the structural formula of the amide that could be produced by the condensation reaction between an amine and a carboxylic acid, given their structural formula. Identify the products of hydrolysis of an amide, given its structural formula. Now, amides, you can find it, you hear that in biology quite often now, so I'm pretty sure. It's building block of all the proteins anyway. If you put amides together, it forms polyamide or polypeptide, it's called. Then that would just make big macromolecules, protein molecules, yeah? In terms of just one unit of protein, so amide, on its own, it should have the following functional group as a part of the molecular structure. Now, what it needs to have is it needs to have nitrogen bonding to hydrogen, and that's directly connected to carbonyl group. Alright, so that's the molecular structure for the amides, and their bonds so should be connected to some sort of alkyl group. Alright. So while small molar mass amides are not very common in nature, polymeric proteins with amide groups as linkage are very, very common. Right. Theoretically, an amide could be prepared from a condensation reaction between ammonia or amine with a carboxylic acid. So how does it look like? How does it look like? Sorry. Let's go with amine. Nitrogen here, 2 hydrogen. What's the classification of this amine? What's the classification? Primary. There's only 1 carbon. So that will be just a bit of revision there. So primary amine. And if you have a carboxylic acid, I'll reverse the usual look. So HO here, R1 here. So similar to what you saw with the esterification reaction, the water can come out. Yeah, that's why it can be called condensation. So what would come off? I would say this again, and this. Yeah, so hydrogen and the OH group there should make water. So resulting product should be something that we just drew it there. So R and H. And now nitrogen is directly connected to carbon. Oxygen double bond carbonyl group. And another carbon chain. And because this is a condensation reaction, the other product is water molecule. So theoretically speaking, that could occur. But in practice, if we try to do this in laboratory setup, what we usually get is the proton transfer from acid to the basic ammonia or amine group, forming a ammonium or substituted ammonium salt, as it's written there. So alkyl group, which is in the carboxylic acid, and ammonia group or amine group, which is here. The acid will just transfer its proton to amine, which is base. Okay. So even though you want to create amide group to connect amine and carboxylic acid, it's actually pretty hard. Acid-base reaction is much easier to occur. Okay? Hence, assume that the condensation reaction occurs successfully for any question that given. So if a question in the exam was saying that these were the reactants, and assuming that the reaction occurs to make an amide, you just have to assume that that's going to happen. Okay? So that context should be given. All right? But yeah, if it's acid and base, well, that's a reaction that's very easy to occur. It's spontaneously happening instead of you heating up or whatever. All right. So make sure you can also draw the structural formula of the amide product for any given reactants. All right. So you could have, so looking at this amine here, and also carboxylic acid here, you could have different lengths of carbon. You could have another carbon here with branch, I don't know, but you could be given any combination of it. So make sure you can draw amide group with theoretical, assumed context. On the next slide, amides are much more difficult to hydrolyze compared to esters. It means required extended reflux under a strong acidic or alkaline condition. Now, there is acid hydrolysis of amides and also alkaline hydrolysis of amides. I think they are the last two slides on amides. So let's look at page 274. So there are two equations that I would like you to copy. Firstly, for acidic condition. So if you have a amide group could be R dash and with two dashes, dash dash dash, double dash. Hydronium ion being the presence of acid. With reflux as it's one of the reagent condition setup that's necessary, you can then split that into carboxylic acid group and amine group. Oh, actually, apparently this should be a ammonium or amine, but protonated amine.
Should that be I dash?
Yes, thank you. So similar to what we talked about before, when an amine has got extra bond connected to another hydrogen, nitrogen is the one that's positively charged because that's the one that's kind of stolen its electrons. Yeah, one of them could be hydrogen, or both of them could be hydrogen, depending on what you start with. If this one had, two hydrogens here, these alkyl group could be hydrogen, not carbon chain. Okay. All right. When you have acidic condition, you could also have basic condition. What do you think you'd get? One of the product was carboxylic acid in acidic condition. Good. What ion again? Namely carboxylate ion. And that's a very good guess, and that's what should happen. So reactant-wise, it's the same. Let's stick to that. Okay. So instead of carboxylic acid, you now get carboxylate ion. Because it's very hard for acid to exist as acid in basic condition. What do you think would happen to amine? In acidic condition, amine, which is base, was protonated because there are so many protons around. So when it's in basic condition, what would happen? What do you? Did I make any mistake?
No, it's not.
Both. Thank you. No. Yeah, that's right.
There's an L.
I don't know how I spelled that, but carboxylic. I spelled this one right, I'm pretty sure. Carboxylate, yeah. I don't know how I did that one. Alright, in basic condition, base can stay as base. So, you should just get an amine. Okay. One thing that would be different from esters hydrolysis would be the arrow here. Do you notice that that's one-way arrow? Yeah. Why is that?
It's the rules.
What did we say about condensation regarding amides again? Practically, it is impossible. Yeah, practically, it's very hard for you to do because acid-base reaction should occur instead. Yeah. So yeah, backwood reaction is not something that would occur, but still need heat and extended time of heating. So yeah, Yeah.
Does the N on the bottom one have any like charge sort of thing like that?
No.
Okay.
So yeah, carboxylic acid would be carboxylate ion, but because it's in basic condition, the base would stay as it is. In acidic condition, acid should come out. Yep. Alright, so I hope you find the right places there. So alkaline hydrolysis of amides, that's on the next slide. And one last note there. Make sure you can identify the products depending on the reactants and condition given. So in the exam question, you could get any sort of amide, and it could be saying acidic condition or with a lot of base in it. You know, depending on that, you need to be able to draw the combination of carboxylic acid and protonated amine, or carboxylate ion and amine. All right. Have a go at questions, please. Or if you would like to finish working on the drafts for organic, you may want to maybe do that. Maybe you have just submitted. You do. I have to just work on it instead.